Hi, it's Jan Beta, and today I'm going to take a look at this old NAD or NAD 7020e receiver from the 80s. This is a classic NAD stereo receiver 7020e that I got from a co-worker, I think in exchange for something I repaired for him. Don't quite remember, it's been a few years, and since then this has been sitting in a box in my basement, and I didn't really take a look at this at all after I got it, and just recently remembered that I had this sitting in a box. So today's the day that we're going to clean this up, check it, and see if it still works, and if it doesn't, possibly try to repair it. This is not a very powerful receiver. I think 20 watts output, 2 times 20 watts for left and right. It uses the same output circuitry, as far as I know, as the classic NAD 3020, which is considered by many a very good sounding amplifier. And I worked on one of those before, and it indeed sounds pretty great for what it is. Pretty simply built amplifiers, built down to price. This one is no exception. Looks really simple and clean. Not clean in the sense of being not dusty, but from a design point of view. It has a digital red LED display here for the tuning, I think. So much simpler than the good old 70s and early 80s receivers, which had this scale and a huge dial. This just has some buttons to change the station, and it remembers 5 stations, it seems. I haven't really tried this, and I haven't really researched this thing. Just want to see if it still works. I think the co-worker I got this from said it would still work, but had some problems. I don't remember. We're going to see. So first thing I want to do is to open this up, because I can already see some dust in there. We're going to remove all the dust as the first step before we even try to power this on. And I think there's 4 screws on the sides and 1 screw here for the top casing part to come off. Ah, there we go. Doesn't look that bad. So it is pretty dusty, of course. It has these large cooling vents on the top here, so all the dust gathered for all its life. This doesn't look like it's ever been opened before, so we're probably the first people to see this from the inside, except the ones who assembled this at the factory. So I'm just going to go in here with a brush and my vacuum cleaner and clean off the surface dust, which is also going to make it a lot easier to spot burnt components and cracked stuff. So let's do that. Just using a regular vacuum cleaner with one of these attachments here. These are for cleaning PCs. It's a brush with a hose that connects to a regular vacuum cleaner, and you can just brush and suck at the same time. So this is really useful for things like this. It does look to be in quite excellent condition, actually, after removing the dust. I don't see any bulging caps, but these older ones, as you can see on this one, for example, they don't have pre-cut tops. So the leakage, if they leak, usually happens on the bottom. I see some glue around these here, but I don't think it's electrolyte. So chances are that these are not leaking, but they might be dried up. So these caps are really old, and these NAD devices have a tendency to have bad capacitors in them. Yeah, power supply section. These are the main power amplifier transistors, and there's some smaller transistors here that are the drivers, I think, the driver stages. Rectifier diodes huge ones. They also don't look burnt in any way. We are going to check the fuses. I think these fuses are for the output, the speaker protection fuses. This doesn't have a relay-based circuit for protecting the speakers. So built down to a price. This whole section here is the receiver for the FM and AM radio that this has. All looks nice too. No burnt stuff on there. I think I would even dare to power this on. Let's just measure the fuses. If those are alright, we're just going to try to power this on for a bit, I guess. Just using my multimeter in continuity testing mode. So it beeps if we have continuity, and I'm just measuring the fuses here from one terminal to the other. That's all the fuses, 4 fuses. Yeah, these are all glued down, the larger caps, it seems, and there's the brown glue under those that has a tendency to become conductive. But this is a one-sided circuit board, so on the top side where the glue is, there's nothing too much to worry about regarding conductive glue. Yeah, everybody seems pretty good, actually. Let's give this a bit of a closer inspection, just looking for burnt resistors and capacitors, things like that. Capacitors that are bulging, burnt little ceramic caps. Just going to inspect what I can here. Of course, there's a lot more going on under the receiver board. You might want to take that out. There's a lot of capacitors under there. But yeah, the parts I can see clearly now are actually alright, it seems. There's 2 transistors glued to the side here. Or screwed to the side with some heatsink thermal compound. Yeah, it does look pretty good actually. It smells a bit like my basement, but it does look good. So I think we can get the dim bulb tester out and try to power this on for the first time in ages. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you, everything the tinkerer needs. And they have several special discounts going on at the moment, including getting purple PCBs for free, which usually cost extra. So you pay for the PCBs, but not for the purple. Purple solder mask for free in September. So I highly recommend checking out the link in the video description in case you're interested. Back to our NAD. So this is my dim bulb tester, just a regular incandescent light bulb wired up in series with the mains, basically. So the mains is going through the light bulb before it reaches our receiver or whatever we want to test. And the light bulb, the brighter it gets, the more current it limits. So you can see the current draw of this device. If this stays on full brightness, basically there's something shorting out in the amp usually. Usually what we're going to see is this light up bright for a brief moment of time until the capacitors are charged and then go to a dimmer glow. And that's a sign for nothing being horribly shorted. And in case there is something shorted, this is going to limit the current and help prevent damage to things that are behind or connected to the damaged parts. If the transistors are shorted or something like that, this usually prevents the other transistors from getting too much damage. Yeah, long story short, let's just try to power this on and see what our light bulb does. Giving a juice to this. Let's try. Yay! Okay, that doesn't look too bad. Light bulb is still lit, very dimly, and we even have a display. And we can search stations. That is pretty neat. It seems it's working. It doesn't find a station because I don't have anything connected here in terms of... oh, it's going backwards again. I don't have any antenna connected, so it's not going to have the best reception here. And probably not enough reception to consider a station a good signal. Yeah, but this seems very promising so far. The search seems to work, and we don't have anything horribly shorted in here, it seems. Nice! I think we can try this without the dim bulb tester probably, and possibly connect some headphones to it and see if we get any output from it before I connect my good speakers. We can also check the speaker terminals for DC voltage, which would be pretty destructive for the speakers you would connect to this. So let's see if something is wrong with possible DC from our speaker terminals here. So I'm just connecting my multimeter again. Set 2 volts DC. And we're just going to stick it in our terminals here, which are these spring-loaded type, which is not particularly good. Just turning this on again. That looks pretty good to me. That's minus 0.56. Yeah, that's very, very close to 0 volts. That's 2 millivolts. And of course it's stabilizing because all the capacitors charge up and the transistors get to their operating temperature. That looks really promising. Let's check the other channel. Just going to turn this off again. And I'm running this without the dim bulb tester now, of course. So just connecting this to the other channel. Yeah, that's also already low enough, so we're not blowing the speakers. Yeah, so that's all good. So we're not going to damage speakers hooked up to this with DC voltage, which is pretty quick to kill loudspeakers actually. So if you have someone you know that you don't like and you want to annoy, you can kill their loudspeakers with DC applied to them. So yeah, I'm just going to leave the volume down for now. Yeah, we have radio reception, but it's very weak. I think I want another audio source on there. The radio reception is a bit weak without an antenna, of course. So hooked up my old phone, which is so old that it actually still has an audio output. The others have audio output too, but no jack anymore. So I should have something on the video input now. Yep, it works. Yeah, I've listened to a bit of music from my headphones and it indeed just seems to work. So let's hook some speakers up, I guess, and test that. The controls are a bit crackly, but not that bad really. I think we removed much of the dust from them. We have test speakers over my bench here. That should be connected up correctly. Let's see. So, speakers hooked up. Let's test this with something that I have the rights to use. Turned the volume all the way down. It did a little pop. Yeah, there we are. And it does sound really good. That's focus 10, by the way. Yeah, the balance is a bit crackly, but usually if it's just a little bit, you can just twist it a bit and it's going to clean up. And you can hook up an extra pair of speakers that you can additionally power with this, but you can't turn off the first pair of speakers. So it has 2 speaker connection, 2 times 2 speaker connections. But you can only use one or both at the same time. So the first one is always on, that was what I was going to say. Yeah, even these push buttons don't crackle only thing that gives me a tiny bit of crackle is the balance. Nice! Yeah, this seems to be a working NAD 7020e. Okay, it does work. Does it save the channels? Yeah, it does. Yeah, we saved it on 2 channels now. Even that works. Let's turn it off and see if it keeps the channels actually. Okay, turning on again. It kept the channel. Yep. Winner! So I'm just going to listen to some music and report back if I find anything. And of course, in the longer term, I am going to have to replace all those electrolytic capacitors if this turns out to be good, because these are just old. And usually it improves the longevity and the sound quite significantly if you replace these old capacitors against good brand new ones. You can go overboard and put like audiophile, audio grade caps in here, but you can just use regular caps because they are still going to be better than the old caps that are Elite brand. I don't think this is the best brand for capacitors anyway, so replacing these is going to improve things significantly, I think. I used the NAD for some time now, and it actually works mostly completely flawlessly. Sounds pretty good, but I still want to replace the electrolytic capacitors in this. So that's what we're going to do. I ordered some of the less common values that I didn't have at hand, in particular the big 4700 microfarads 50 volts filter capacitors, responsible for filtering the rectified voltage from the transformer for powering the power amp section in this. And most of the other capacitors I should have in my parts bin. Not going to be too precious with this, but I'm mostly going to use Panasonic FC series, which I've used in many hi-fi equipment devices with great success, usually pretty good capacitors. This is not going to be super interesting because I'm basically just replacing all the electrolytic capacitors in this that I have in stock with the same values, same capacitance values. Voltage-wise, I'm going with the same voltage that was in here originally, or slightly higher voltages, which usually works fine. You can just use regular run-of-the-mill electrolytic capacitors. I like to use good brand ones, and in particular the Panasonic ones that I talked about. Usually that makes the devices run a lot more stable. Most of the times it's not strictly necessary to do this because the capacitors are still tolerable in these, but this is a device from the late 80s, so the capacitors are going to be at least a bit compromised. Also given the fact that these are not the best brand capacitors as far as I can tell. And the NADs I've seen so far had a lot of bad capacitors in it. I don't think these are all bad, but some of them probably are marginal at least, so it doesn't hurt to replace the capacitors. I'm using my desoldering station and my regular soldering iron here, going one capacitor at a time and making sure that I put them in the correct orientation. These have a polarity. Usually they have a stripe for the negative polarity, like these big ones, and you don't want to reverse them. And also you want to make absolutely sure that you use the same capacitance unless you exactly understand what this circuit does and can upgrade the capacity. Some people like to upgrade these filter capacitors to higher capacitances. but that is going to put a bit more stress on the transformer in the units. So I mostly just go with the same values and modern good brand capacitors. These are actually Nichicon, which is a good brand. The rest of them are mostly going to be Panasonic because that's what I have in my parts bin. So long story short, let's open this up again and replace some capacitors. An exercise I actually like doing a lot because it's kind of a meditative task for me. Not going to talk much. There are some capacitors that are a bit strange in here. Some of them I don't have replacements for, but I'm going to talk about those when we get to them. And this NAD, as many amplifiers from that era, has kind of a service plate here. So you can take the whole bottom plate out to get to the circuit board from the backside, which is pretty handy. So we don't have to take the circuit board out. I think we're going to have to get the receiver board out here. I'm not even sure if I want to recap that because I'm not going to use the radio receiver in this. Yeah, I'm just going to open this up from both sides so we have access to all the caps and then replace them. There we go. Yeah, and this actually looks pretty nice. This is still a hand-drawn circuit board. You can see by these wavy lines here. Somebody drew this by hand with a marker on a piece of paper, presumably, and then they photocopied it to a circuit board. So that's pretty neat. I love seeing somebody's artwork on here, really. So it's old enough to be hand-drawn, actually, and not computer-generated traces here. So some of these solder joints here are not super easy to access because there's this metal frame here that's screwed in from the top of the circuit board, from the back of the casing, and from behind our front panel here. Might as well remove this. I think, yeah, it shouldn't be that hard to remove the front panel here. So we have to remove these knobs here and the volume knob. I think I'm just going to center all of these. You can just pull these out. And then we have some screws. One screw here that's left over and 3 screws here that we have to remove, and then we can pull the whole plastic cover out, I think. And then we have access to the screw for that metal rod there. It's just a stabilizer, basically. And this one. Yeah, there we go. That comes off now. So this is what this looks like naked, basically. There's a Toshiba LED driver chip, I assume, is what this is. And some tiny tactile switches here. So yeah, there's our screw that we have to remove to get that bezel out, I think, and the screw on the back. And the screws from the top. And the same on the back, probably. And then we have 2 screws that go from the top side here through the circuit board. And this rod stabilizes the circuit board and the casing. Very efficient again. Yep, it's loose. Yep. Okay, now we have full access to the whole circuit board from both sides, which is what we need. So I have some air filters running now. The larger caps are glued to the bottom of the, they're glued to the circuit board on the bottom, so yeah. Going to have to do some wiggling there. These actually have a date code, the original capacitors, 588, so this was made in 1988, it seems. So I broke off the glue there. This is not so easy, but I have one of the large caps here. There we go. That's a 3-pin with the glue still on it. But there's only 2 pins on here that are actually used. I'm just heating the legs here and wiggling on it because there's glue from the other side, which is preventing me from getting this out. Okay, there we go. This third pin on here is just a stabilizer, so we have positive, negative, and we can just put our new ones in there. Going to clean the glue up a bit, but it's not that bad. So you can see the glue residue here. That is pretty nasty. I'm not going to be able to get that fully off there, but I'm still going to spray some alcohol on there and clean it a bit. You can use something to pry this off, but not really worth it. Sometimes this glue can become conductive. So let's put the new ones in. And this is marked with the dot on the negative side here. And these two are the holes that are actually connected. And I'm probably going to add some hot glue after the fact to stabilize them again. Yeah, then it's just a lot of smaller capacitors. Just going to go through each single one and replace it. So apparently I forgot to film a whole portion of this, but yeah, we're slowly getting there. There's not much happening anyway, just doing the same thing all over again. Removing a capacitor, looking at the capacitor, replacing it, and we're going to clean up the flux residue afterwards. We are going to have to fold this board over in some way soon, because we're reaching the last caps that I can reach without doing that. So there were some unusual caps here. There are two 22 microfarad 100 volt ones, which are pretty unusual. I replaced them with 200 volts rated ones, which should be fine. 100 volt ones are not so easy to get, I guess. So there are two 0.68 microfarad ones here. I'm going to make a note of that and possibly replace them at a later point. But the most important ones for keeping this thing alive are the ones we already replaced in the power supply section. And we have two here on this daughter board thingy that we are going to have to remove to get to them. So there's three capacitors here on this little daughter board thing that we're going to have to remove the screws through these transistors here for. So we're going to do that carefully. Okay, that's not too bad. There's some glue on there to keep this board in place. And there's a nut on this side and a screw on the other. Yeah, I'm going to replace these capacitors here. And then we're going to have to somewhat fold this board over to get to those underneath. As I said, I'm not too worried about these on the board itself. Yeah, just going to put a tiny bit of new heatsink compound on there. Yeah, looking quite good. So now for this thing here. So we have several things that we need to loosen. These two screws here, I think. I think this one, yeah, might be, that's the ground screw, I think, for this board. There's a screw here. We have to remove the speaker. No, the antenna terminals is what these are. And then we can probably fold this over in some way or the other. Just going to remove the speaker terminals here first. not speaker terminals, antenna terminals. So these ones are the exact same screws. And this black one here. Yeah. Ooh, there's a lot of capacitors in there. Okay, so lots to do there. I think I'm going to desolder this ground connection here on our RF can. And then we should be, yeah, now we can fold it all the way to the side. Okay, lots of capacitors under there. This is where our inputs are, so this is pretty important. These should be more or less all in the audio path, and our little preamp transistors are here. So this is an important part of the board for audio actually. This is more or less the power supply section here. So I nearly replaced all the capacitors now. These ones here I didn't have in my parts bin. They are 22 microfarad capacitors that I didn't have, and some 330 microfarad capacitors. These are rather standard values, but I didn't have them at this point, so I just left the originals in. The other ones, except for those small 0.68 microfarad ones, I had good quality ones. As I said, I used mostly Panasonic FC, FR, some FM in there. I think these are all really good 105 degrees Celsius rated capacitors that should be way better than the originals, and they are fresh. These are Nichicans, as I said. So we're going to put it back together, at least put the tuner board back in, and try if this still works, I guess. And I think I want to put a little star washer on our ground connection here, just to make sure that that always makes a good connection. And we need to clean the circuit board, of course. I'm going to do that now. And we're going to use isopropanol to clean this mess up that we made. And some of the mess that was already on here, I guess. And maybe some circuit board cleaner. This stuff is for this purpose. And then we're going to mop up the rest there, the remnants. And I should not forget to solder the ground connection on this here again. Possibly some hot glue on the larger caps so they don't float around. I need to source the other capacitors, and probably if I open this up again, I'm also going to recap the whole radio receiver board here, tuner board. That won't hurt. So this goes back here. Yeah, let's put some hot glue on some of the larger caps here, just like it was, so they don't vibrate too much or resonate in any way. Here's the capacitors are removed so far. There's a lot of electrolytic capacitors in this thing, so if you really love yours, yeah, it's going to be a lot of effort. But they are all pretty easy to reach, as we've seen. At least, I've seen much worse in other receivers. So just some strategic drops of hot glue. Trying to make sure that I don't hit any components that could potentially short out if the glue gets conductive, which this glue shouldn't, but you never know. So, yeah, we have to put our grounding and stabilizing rod back in on the back side. Just going to give this a quick wipe. Some window cleaner. It usually doesn't hurt the printing too much. And then put this front plate back on. And then we can put our knobs back on, which I also cleaned a bit the last time around that I opened this. Okay, time to try if this blows up, I guess. I read up in the service manual how to adjust the bias and the idling current for the power transistors here. We actually don't want to put the backplate on yet because we have to remove a solder jumper actually to do that. I'm just going to follow the service manual here, and the first thing we should do is to set the little impedance switch that this has in the back, which is here. And normally you would leave that on 4 ohms. It also says normal, but you can put it in 8 ohms mode. There's a little screw to secure it so you don't blow up your amp. Yeah, if you hook anything with lower impedance up to this in the 8 ohms setting, it's probably going to overheat pretty quickly and shut down. So I recommend using it in the 4 ohms setting. If you are sure that your speakers have 8 ohms impedance over the whole frequency spectrum, this might give you some more overhead sound-wise. But most speakers, even the ones that claim to be 8 ohms, are a bit lower impedance these days. So I recommend using the 4 ohm setting. For this setup procedure, we need to put it into the 8 ohms setting, and you want to do this every time you change anything in the amp. So replacing the capacitors. This is going to be factory set up somewhat correctly, I guess, because it worked fine, but we're still going to go through the whole procedure just to be sure it's spot on again. And I'm probably going to have to do this again after replacing the remaining capacitors in the audio section. Although the power section is probably more important for this stuff that we're setting up now. So yeah, let's put this into 8 ohms. I have to remember to put that back. I'm just hooking up my leads here to the left channel. Just sticking my probes into the connectors here. Setting this up to millivolts DC, and we can adjust the bias. Need to plug this in, of course. Turn down the volume all the way. You're supposed to do this without a load, so Let's see if it still works at all. Hey, still powers on. And nothing exploded right away, which is a good sign. So we want to set this up for as close to 0 as we can, actually. And as you can see, it's pretty much, it's fluctuating quite a bit, which is not very great, but it's also pretty normal for an amplifier this old. So this shouldn't go above 30 millivolts. And we can adjust the left channel with VR 411. It's called R411, but I'm pretty sure that this is the one. So it kind of stabilized at 19.2 millivolts. And I'm just going to try to get it as close to 0 as we possibly can. And as I said, 30 millivolts are still perfectly okay. That's pretty good. And then we're going to change to the right channel, which is R412, the adjustment. Turning it on again. And we're waiting for a bit, because this needs to stabilize. R412 is this one. Okay, that's pretty close to 0, I'd say. This is a bit fiddlier than the other one. Yeah, but that's pretty good. Now for the idling current adjustment, we have to remove a short across these two resistors here. This is R456 for the right channel and R455 for the left channel. There's a solar short on the back of the board across these two. And we have to remove this to set up our idling current. So here's our output transistors. These are the output transistors from this side. You can see the screws there and the shoddy ground wiring. And we should have a solder blob between here and here. This is where these are our test points that we're going to connect our leads to later on both channels. And the smaller solder blobs you can see there are our resistor, I assume. And this is the solder blob connecting the two. So we have to remove these solder blobs here. So let's heat up the soldering iron and try to make this not shorted. I'm just going to use my desoldering pump here. Yeah, and indeed that's a short that was deliberately put there. I think so. Let's measure it. Should be 1 ohm. Yep, now it's 1 ohm. And this one too. So our resistors are now in place here. So let's connect our test leads to the test points. And of course we have to put these back after adjustment. So we're connecting these between P404 and P403. And we are adjusting R443, which is this one here. Yeah, so this should be connected. We're adjusting for 26 to 30 millivolts. So we're setting this into millivolts DC again. And we should have a reading on the multimeter in a second. So we need to turn this on, obviously. And we have around 12. This should stabilize in a second, or in a minute rather. So I'm going to let this run for a while until the voltage stabilizes. And then we should adjust this for between 26 and 30 millivolts. I'm going for 28 because that's right between something around 28. Pretty close to what I was after. So we're going to do the other channel. Same thing, just different test points. And then we're going to do the final adjustment. So these are P406 and P405, and we're adjusting R444 for the same voltage. And then we're going to do the same after this has been running for some time. So the service manual says to do the same again after this initial adjustment, so we're going to adjust the 0 point again as well, the bias, and then do this adjustment again. Takes a while until it stabilizes somewhat, but we're pretty close, I guess. There's also a whole section about aligning the tuner section, of course, but I don't have the need for that or the equipment for that, so I'm just going to leave that as is for now until I use it. But they're actually shutting down radio stations here front and center at the moment, so this is going to become, at least the tuner section is going to become obsolete pretty soon. Yeah, that's pretty good. So let's do the 0 adjustment again. So yeah, we're getting very, very close to 0 and very, very close to 5 minutes. It's still fluctuating quite a bit, but remember, these are very, very minor fluctuations. This is on millivolts, so this is a tenth of a millivolt. A microvolt, I guess, the last digit there. So yeah, and you can set this up to plus minus 30 millivolts, so we're very close to 0, which is good. Just going to try to make it a bit more stable there. It's going to be more than good enough. So let's check the other channel while this is running, I guess. This is around 0.4, 0.3, 0.4 millivolts, which is excellent, of course. So now we're going to do the other adjustment again. And I'm going to switch this off while clipping on the test leads there because, yeah, I don't want to mess this up after putting so much work in. And I'm just going to run it again for 5 minutes and adjust the idling current again. Yeah, 5 minutes in and a bit more, and we're pretty much perfectly set up still. So 28 millivolts on these test points. So let's go to the other channel and then we're finished, and we have to close those solder jumpers again after that. Okay, 5 minutes in and we're pretty much spot on 28. So I call this one adjusted properly, both idling current and the bias. That is pretty neat. And it also it stays at the same value roughly. It fluctuates a bit, which is normal. But yeah, this worked out fine. So we're going to have to close those solder jumpers and set it to 4 ohms impedance again and test it. So we're just going to put the solder jumpers in the same spots. Looking good. Should have nice blobs on both of these. Just going to double check with the multimeter if we indeed have 0 ohms resistance there now. And then we can close it up. Yeah, that's 0.3, 0.03 and 0.04. So we have closed our jumpers. So yeah, let's put some screws back. let's hook it up and try it out, shall we? And I'm going to hook it up to the speakers it's actually going to live with for the foreseeable future in my gaming corner. My PC is going to be hooked up to this. So there it is, hooked up to my PC. And yeah, this whole corner is pretty messy, but that's where it's going to live. It's hooked up to these little Denon speakers that you can see there. And I'm using it primarily during streaming, but I also have some music on here. And it sounds pretty good. I think it sounds a bit more responsive than before, actually. The bass response sounds a bit tighter, but I'm not sure. It's very subjective, and hi-fi stuff usually is all psychology, or most of it actually. There are good amps and there are bad amps, and there are good speakers and bad speakers, but it's all a matter of taste in the end. And I actually like the sound of this thing pretty much. I also like these little Denon speakers that I bought for cheap ages ago. They're not bad. And this is Focus 10 who provides the music, which is quite amazing, for my channel for free to me. And you can listen on all the streaming platforms. And if you want to own the music, you can also buy it on Bandcamp, actually. So the links to that are in the video description, as always. Yeah, just wanted to show you that this thing actually still works. I actually listened to music for an hour or so, and it held up fine. So it's definitely a very much working and good sounding receiver. Yay. Yeah, that's it for today. I hope you enjoyed this little excursion into the world of vintage hi-fi, which I do from time to time because I love this stuff so much. Thank you very much for your time. Hope you enjoyed this. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are in the video description or on my website. That's it. I'm Jan Beta. Thanks for watching. See you next time. Bye.